Welcome to AI with Shailey. I'm Shailendra Kumar, your guide to the fascinating world of artificial intelligence and robotics. Today, let's dive into some groundbreaking updates from the Soft Robotics Lab at ETH Zurich, a true hotspot for innovation on the robotics frontier. Picture this, a playground, but for robots. That's how the lab sets up its workspace, a place scattered with toys where robotic hands are trained to master dexterity, not with rigid gears, but with soft, tendon-like structures that mimic human anatomy. It's not your average mechanical tinkering, it's biomimicry at its finest. Back in September 2025, one of the lab's spin offs, Mimic Robotics, secured seed funding to develop humanoid robotic hands with near human finesse. Their AI models learn by watching real human demonstrations. Imagine a robot pupil in a masterclass on how to grasp, pinch, or even play an instrument. Stefan Weirish and Stefan Gravert, former students, now lead this charge, demonstrating the power of marrying deep academic research with entrepreneurial spirit. But here's what truly sets this lab apart. It's their approach to materials and actuation. Instead of relying on traditional motors, which tend to limit flexibility, they harness soft, rigid hybrids and even grow artificial tendons. Chemists in the team develop electro-stimulated muscles, creating movement that's silent and surprisingly lifelike. This blend of biology, chemistry, and engineering is something I find truly exciting. It reminds me of when I first worked on adaptive AI systems. Success came from looking outside the box, pulling inspiration from nature and unexpected places. In November, the lab's cutting-edge research made it to the cover of Advanced Materials thanks to their advances in volumetric 3D printing and melt electrowriting. These techniques allow for fabrication of incredibly complex soft robotic structures. Think of it as 3D printing stepping up its game to build not just shapes, but lifelike flexible components that can adapt and respond like living tissue. And as we look ahead, the lab's work speaks to a bigger vision, robots that safely interact with humans and nature. Professor Robert Kuchman often highlights sustainability like underwater robots with quiet muscles to reduce marine noise pollution. It's a gentle reminder that AI and robotics don't have to be disruptive, they can be harmonious extensions of the environment. So here's a question for you to ponder. As we create robots that move, think, and even feel more like us, where do you think the line between human and machine will blur first? And what could that mean for everyday life? Before we wrap up, here's a bonus tip. When exploring new AI and robotics tech, don't just focus on the algorithms or hardware alone. Investigate the materials and biological inspirations behind them. Often, the biggest breakthroughs come from the intersections of disciplines, just like at ETH Zurich's Soft Robotics Lab. As always, I leave you with a thought from Alan Turing himself. We can only see a short distance ahead, but we can see plenty there that needs to be done. The work at ETH Zurich is a vivid example of stepping boldly into the unknown, shaping a future where robots adapt alongside us. Stay connected with me on YouTube, Twitter, LinkedIn, and Medium for more AI insights. Don't forget to subscribe for your regular dose of AI news and share your views in the comments. After all, your perspective is what keeps this conversation alive. Until next time, this is Shailendra Kumar signing off from AI with Shailey. Keep curious, keep questioning.